Hello everyone. Today in this video I'm going to show how to use Fortran programming to find the Lagrange interpolation of the given data. Interpolation is the method of constructing new data points within the range of given discrete set of known data points. By interpolation, we can find new set of data. A continuous function f of x may be used to represent n plus 1 data values with fx passing through n plus 1 points. And we can find the value of y at any other value of x. This method is called interpolation. If the value of x, if x falls outside the range of the given values of x for which data is already given, then this method is called extrapolation. A polynomial is a common choice for interpolating function because polynomials are easy to evaluate, differentiate and integrate relative to other choices such as trigonometric or exponential series. Now we are going to use Lagrange interpolation. Lagrange interpolation is also a method of polynomial interpolation. We find the Lagrange polynomial from the given data and interpolate the data. Let's make a file lagrange.f9t and write our codes. Program Lagrange interpolation. Implicit non, real we have xg. This xg is the value which we enter to be interpolated. L and sum integer are n, j and k. Real dimension. In real dimension we have 4 data in this data set, so we are going to write 4. We have x and y. Now we just state our data. 2.0, 3.4, 4.8 and 6.2. Data for y, the y data set is 3.3, 4.6, 5.9 and 7.2. The number of data is 4. Now we just ask the program to insert our desired value. Please insert the value of x at which y is to be interpolated. Read star comma xz. This we are going to insert. Initial sum is 0. Do looping, do j is equal to 1 up to n, L is equal to 1. Do k is equal to 1 up to n, if k is not equal to j, if k is not equal to j, then L is equal to L star xz minus xk by x by xj minus xk. And if and do. Sum is equal to sum plus L star L multiplied by yj. We have two do loops. Here is one, we ended it. Similarly, next do loop also must be ended. So into print star comma the interpolated value at xz is sum, and program Lagrange interpolation. Lagrange interpolation, and program Lagrange interpolation. Hope everything is fine over here. Let's save this program and go to the terminal, compile the program, the Fortran Lagrange .f90. Oh, here a parenthesis is missing over here. Let's correct it at 18. At 18, what we did is L multiplied by this one is closed, and L multiplied by xz minus xk, and we just this one is missing. Let's save it and let's compile it again. Yes, the error has been corrected. A dot out. Now let's enter our value. For example, we want to find the interpolated value for x equals to 5. Let's write 5. The interpolated value at 5 is 6.08714434. This is our value. Let's format it. Now, how we can format? We have string over here. Here also we have a string. Here also we have a string. This is a string. this is our integer, this is a string, and this is our value. So just the bracket a, let's give a space of 1x. This is I1 a 1x and 1 2 3 3.1 f of 3.1. we need something of, here we have 3 characters for y, so we are going to give 3 characters, 1 after decimal point. Then just close the bracket, then just add the inverted comma and let's save it and recompile the program. 5. Oh, so we have decimal over here. Here also we just make it, instead of integer we just format it as similar to that y and just recompile it. A dot out 5. Yeah, the interpolated value at 5 is 6.1. Here we need a little bit of formatting between this 5.0 is 6.1. Let's go and just let's give it as 2x. This basically inserts 2 space. Here also let's make it as 2x. We are just formatting our previous results. Yeah, the interpolated value at 5 is 6.1. So we had the data 2.0, 3.4, 4.8, 6.2, and in between 4.8 and 6.2 we have 5.0. So for 5.0 we are going to have 6.1. This is what we found after Lagrange interpolation method. We can just find the Lagrange interpolation in next way as well. For that we go to terminal again and just make a next file Lagrange 2.f90 program Lagrange interpolation. Lagrange interpolation implicit non real xz l sum integer n I j and k real dimension. Here we do not specify the dimension, so we just write colon over here. We make it allocatable, so we can enter any number of data by assigning our dimension. So x and y, we allocate them. print enter the number of dimension. It asks us to enter our dimension of the data, read star comma. So we can use this program for any number of any set of data. Now allocate x of n. Similarly allocate yn. Now print enter the corresponding value of x and y respectively. Here we use do loop, do I is equal to 1 up to n. Here we just enter the dimension number, we allocate the dimension data with the dimension, and we use do loop, and we just enter our data. The computer asks us to enter our data up to what dimension we have assigned already. Now and do print star comma enter the value of x at which y is to be interpolated. Now read star comma xz sum is equal to 0. Now everything is similar to the previous method. From here sum is equal to 0 and do print, everything is similar. Just copy. Since it is similar to the previous one, I am just copying the data, copying the codes. Lagrange interpolation. This we have just assigned a dimension and we just enter the data here. We allocate, we use allocatable, and in this one we already wrote the data. The second program, this is quite flexible, we can just make corrections, we can just enter any number of data, any set of data in this program. Then let's save it. Hope everything is correct. If not, we will make necessary corrections and just recompile the program. Fortran Lagrange 2.f90 ./a.out. The number of dimension we have 4. So now we start to write the data. 2.0. For 2.0 we had 3.3. For 3.4 we had 4.6. For 4.8 we had 5.9. For 6.2 we had 7.2. Now we need the value of x, 5.0. For 5.0 we have 6.1. Similarly, in the Lagrange.f90 .out, For 5.0 we had 6.1. So we got the same answer. Here we had already fixed our values in the program, but in the second one we just asked the program to enter the data of our choice, the dimension of our choice, the data of our choice according to the dimension pre-specified, then we enter the value, then answer is received. This is how we can use Lagrange interpolation to interpolate the given data to find the value of y for the given value of x. Thanks for watching this video. Please stay connected for upcoming videos. Thank you.